Hello and welcome to 12.3 lateral area and total area of pyramids and cones. Now the last time we were in class we talked about prisms. And if you remember, if we drew a prism, this just meant that the three-dimensional object actually had two bases, the top and the bottom. Now pyramids and cones only have one base. If you really think about it, a pyramid only has a base on the bottom, right? And as well as a cone. A cone does the same thing. And obviously, a cone is circular, has a circular base, versus a pyramid has a polygonal shape. So you could be a triangle base, a square base, rectangular base, pentagonal base, whatever have you. It is a pyramid if it's a polygon base. So let's define it. Pyramid, just really quickly. We just talked about it. It is a three-dimensional solid with one polygon base and one vertex as the opposite base. Now, that sounds weird because I just said there's only one base. But if you really think about it, it's just the point. A vertex is just the point. So when we drew that pyramid earlier, this point, this vertex, serves as the height or the altitude or the other base, if you will. So it's just the point. There's actually no area to it. It's just a point. Now, if, for example, let's draw this again. Let's draw a square base, a square pyramid. Let's make this a little bit simple because there's going to be some new definitions, I guess new-ish definitions. A square pyramid. A square pyramid, and this can be tricky to draw. Once again, I would start from top to bottom. So I would start drawing the face. And then I would draw probably one side. You won't be able to see that back side. And then we could just start drawing the square base. Okay? We can't see the back side, and there's a lateral edge that you can't see, but I'm going to make this dotted because right now we have two faces. I drew one more line almost straight down. We could continue to draw the square base. Okay? And here we have a square pyramid. Okay? Now there are some definitions that we do need to know. Once again, like I said, we have lateral edges. So for instance, this piece is a lateral edge. And what that really just means is that we have a corner, really. We have two planes that are meeting each other, okay? And they make a sharp turn, okay? Then we also have an altitude. So let's do that in green. It goes from the bottom of the base straight up to the top, the vertex that we were talking about. And we call this our altitude. Okay? This is the height of the pyramid. And it is also perpendicular to the base. So this is a kind of like a star. This is perpendicular to the base. Okay? And then we also have slant height. Now, the altitude goes directly down. Slant height is slightly different. It starts at the vertex just like an altitude does, but it actually goes pretty much down the side of the pyramid. Okay, like the surface of the pyramid. And what this actually does is it creates, and I should have done this here. I should have made right angle for the altitude. The slant height, so let's actually put this here. The blue line is what we call a slant height. And we use the letter L. I'm going to make a cursive L to make that clear. And what this does is it is a perpendicular bisector to the base edge. So this is also a star to the base edge. Now, just like how we have lateral edge, it's where two lateral sides actually meet. Base edge is where the lateral side meets the base side. Okay? And then obviously we have lateral faces that goes all the way around. In this particular case, we have 4 of them because we have four actual faces to this pyramid. The back side and then the far left that we can't see. Okay? So we have lateral faces here too. Just like before. Now to the actual equations and solving for the lateral area. Lateral area is actually pretty easy, pretty straightforward. So let's call this the lateral area, LA, of a pyramid. And that is equal to 1/2 the perimeter of the base I'm going to put that like lower in like a subtext times, and we use L for the slant height. So I'm going to do that in blue. So this is our slant height, just in case you misinterpret that. Okay, so we definitely need to know what that slant height is. So we're going to have some trig or 30, 60, 90, 45, 45, 90. Or if it just gives it to us. Now, we also have total area. So let's call this TA, or surface area, where we would just include the base, right? Just like before, surface area, surface area is just the lateral area plus the bases for a prism. In this case, we only have one base. So total area of a pyramid is equal to lateral area plus the base, area of the base. And once again, I'm going to do like a subtext for that. Okay? And that's it. We're not going to go over an example. We'll do that in class. But let's also talk about cones. Cones have the exact same premise of a pyramid, except we have that circular base. So this one's not too bad to draw. So let's talk about cones just really quickly. As we know, it is a 3D figure, or 3D solid, with a circular base. And vertex opposite of the base. Okay. And to draw one, let's start with the top. Let's draw like what appears to be a triangle. Okay. And then we're going to draw a half circle, like a pizza slice. And then we're going to actually draw a dotted line around on the back side that we can't see. And that completes our cone. A couple things that we do need to know is that we have, I'm going to do this in green again, an altitude. So that starts at the vertex, goes straight down. Once again, this is perpendicular. And that looks bad. Sure. We have a radius. We also have, this is what, like I said, this is our altitude or height. And then we also have a slant height again. The slant height is pretty much what just running down the surface of the cone. So here we have slant height. It is on the actual surface of the outside, and we denote that with the letter L again. Okay. Now the equations. Lateral area of a cone is equal to 1/2 the circumference multiplied with the slant height, L. In other words, we know what a circumference is. We can actually call this, if we break this down, it's 1/2. If we want to use 2 pi r, that'd be great, because it's actually going to be easier, 2 pi r times L. But if you notice, we have a 1/2 here and a 2 here. 1/2 and 2 actually cancel each other out. They make 1. So area of a cone is actually equal to pi times the radius times slant height. Okay? So that's actually really easy if you really, really think about it. Now, total area. Just like before, all we have to do is add on that base, and in this case it's a circle. So total area of a cone is then equal to lateral area plus area of a circle. In other words, we could use this equation in here, and we could call this pi times radius times the slant height, plus we know the area of a circle is pi r squared. And there we have it, our two equations for lateral area of a cone and total area of a cone. All right, we'll definitely do examples of this in class. If you do have any questions, please ask, and I'll see you in the next one.